This is my great pleasure to introduce you with Professor Shahar Arzi, who is live with us from Jerusalem. He's the director of the Computational Neuropsychiatry Lab at Hebrew University and also a neurologist at the Neuropsychiatry Clinic at Hadassah Medical Center. I hope I'm pronouncing correctly. So Shahar is mostly interested in the human self, and as a clinician is also very much interested in trying to understand alterations of the experience of the self, both psychologically and physiologically, and is in particular interested also in Alzheimer's disease. Just one note before leaving the floor to Shahar, I believe he would love to see you and eventually hear you, so don't hesitate to leave the mic on, except if you receive intempestive messaging and other phone calls, of course. Also, feel free to ask questions directly during the talk. I think Shahar would appreciate that also to make it lively. There you go. The floor is yours, Shahar.
Yeah, thank you so much. It's really difficult because I don't like big conferences. Maybe I'm not a star enough or just such personality, but I do like so much these small conferences or people who come. I just been to Harvard for 3 years, and it's so nice that all the world is coming to Harvard, and you can really see the persons behind the PDF and discuss things with. Well, how about it's the United States, but Paris and La France and culture, person, so I really feel bad that I'm here in my little office here and not with you. I hope that this can be compensated very soon. Sorry for with this problem to show my little view, but I think for science such critical. It's always like this, but with you and with what you represent is even more. So the topic of the talk about scales, I think, is very relevant to all of us in cognitive science, even in neuroscience, in clinics, and it's even more relevant nowadays with the restrictions that we are facing, and not only what that we are facing as healthy persons, but also with the results of this that we see more and more, and will see more and more in clinics. I just gave an interview to the Israeli TV broadcasting because they wanted to speak, Virginie, about time, like the Corona and time. I said I don't have much to say about Corona and time, but there is much. Our connection between space, time, social networks, and the default network, and if space changes and the social network change, so the default network may change, and this also affects time. And I will try to explain it in a more scientific way in the coming 50 minutes or as much as we have. And please feel free to ask questions, to open cameras, to open the mics, whatever. I will do my best to make it at least a bit interesting and even helpful for everybody's research. So we will speak about these three domains, space, time, and person. I do remember the conference that Professor Dehan organized in 2009 about space, time, and number. So at least two of them are here, and space, time, and person are based on numbers. So actually, maybe I had to discuss the difference between mental maps, mental models, and mental lines. But well, we have to leave something for next time. And why space, time, and person? Because this is where life happens. We live in space. We have the arrow of time that directs us, and we live with person around us. And what we are interested in the lab are the mutual interrelation between cognitive processes of space-time and person. The relation, the most interesting, is the relations between the experience itself and the processing of space-time and person. And I won't have time to present it much in this talk, but we also claim that the main cognitive disorder in Alzheimer's disease is the breakdown of this system, and we have even a mechanism behind it. So this is for the not for the next time, but for the third after that I present the method. But for today, let's start with the space, time, and person, and you can see more in our website, neuropsychiatrylab.com, and in the recent TICS paper with Dan Schachter, who was my host at Harvard. Just a little one image that Amnon Daphne Meron from the lab did recently as a meta-analysis on more than 1,000 studies on space, time, and person. So first of all, there are more than 1,000 studies on person, or 1,300 in the last 30-something years. And also, if you do a meta-analysis of all of this, you get something that resembles the default mode network. So this is just a teaser for the next for the talk. And as a base, the main idea about scales was that usually in the lab we ignore scales. If we are electrophysiologists or people who work with animals, usually the experiments are done in a cage. Now, a cage is not very big, and as you know, usually a mouse territory is a field. So the field will be like much bigger, so like 30,000 square meters, much more than the cage, which is less than half a square meter. Also for people, so this is like the famous arena that everybody uses after Nile Bourges, but we are navigating in a much bigger scale. Usually we don't have lockdown than an arena. And also we have to speak about ecologically valid studies. Because if we navigate usually in our area, like our neighborhood, our surroundings. And if let's say that I had the chance to see you in live, and I would come to Seattle, to Paris, and it probably brings with it like all my good memories from Paris, my good memories from. So I do mental time travel, and all this cannot be included in a simple VR-based experiment. So what I would like to encourage you in this talk is, first of all, is to be aware of scales and to do the studies in an ecologically valid manner. And again, just as a teaser, you can see that there are even behavioral differences between scales. This is an old study on time that it's a poster that I presented at 2009 in Professor Dehaan's conference, and this study awarded me the ticket to the conference. So we see that there is a difference between the scale, the immediate scale, like the months, and the years. These are reaction times, and reaction times to things that happen in the last month are much, both in future and past, are much higher than the years. And if we speak about scales of proximity in society, so people who are very, very close are different from people who are not that close. Again, I will delve into details, just a simple behavioral manner to show that scales matter. So first, what I'm going to do is first to introduce a brain processing of space, time, and person. This is a study from 5 years ago, so we'll do it very briefly. Then we will speak about how the brain represents different scales, and we do it in space and in time. These are two papers that are already published in ELAC and in Virginie's section in Journal of Cognitive Neuroscience. And then how does the brain represent multiple scales in the same time? And this is a new study that I hope to submit like in 1 week or two. So it's fresh from the oven, and it's even related to mental time travel. And this is what makes it more interesting for today. Then multi-level scales in social level, we won't have time probably to show today, but well, let's see. So the terminology that I like to use is orientation. Why orientation? Orientation is defined by Gales 82, didn't catch up, tuning between the subject and the representation he or she forms of the corresponding public reference of the external world. And though there is a lot of literature regarding spatial navigation and regarding time and memory and regarding social cognition, but what is a mechanism that relates the behaving self to these cognitive models or mental models of the environment? So it's since I don't have a very good term to it, I use the term orientation, which actually in clinics is very prominent, because each patient who is coming to the emergency room has first, especially in neurology and psychiatry, but always to be evaluated with respect to space, time, and person. Now, unfortunately, and after the mini-mental, so people test orientation, like what is the date today? Now, I have no idea what is the date today. It's supposed to be something, actually I know, because tomorrow is Nikolai's deadline. It's March 2nd, so today is March 1st. But otherwise, especially now with the lockdown, February, now, 21, 22. So, no, 21, 22, somebody has to know, but not more than that. So people make mistakes. People are, especially people who are living alone and older age, and they don't have a disorientation. And the same in space. Like you have to be really disoriented not to know where are you right now. For example, Professor Dehan told us that he's at home now. He didn't have to think about it. It's just there that you are at home or in the office. So the test made a bad reputation for the so important term of orientation. And that's why nobody today almost does this orientation testing in the hospital, because you don't have to do the test if you know if the patient is with us or not. It doesn't have an important informative level. But the term of orientation, how we are referred to the surrounding, is so important. So the simple test that we designed is to check a closeness or cognitive distance, led by Michael Peer, who is now a postdoc with Russ Epstein, and published in PNAS 5 years ago. And the manip was always the same, to show two cities or to show two events or to show two people, and then ask the subject to decide who is closer to you, this or this. And we did it in a 7 Tesla MRI. And the interesting thing was what we call gradients. Now Daniel Margulis also worked on it. That a gradient that goes from space to person to time, space, person to time. This is in 7 Tesla, so it's in the individual subject level. This is the retrosplenial cortex, precuneus, and you see similarly in the temporoparietal junction. And well, it's highly significant in whatever way you look at it. This nice several colors here show you that there is a core region in the retrosplenial cortex who is common to all of the domains, space, time, and person. And then there are domain specific and some others. At the time, actually, until recently, I thought that there is a person orientation region, which is more anterior, and the space orientation region, who is more posterior. Now I have another thought about it that I will be happy to share with you. We also compare it to the default mode network, and we found that the person orientation region overlaps the default mode network. That's what we thought at the time. Then, together with the work by Randy Buckner that I will show about the DNA and DNB, so we think differently. Actually, Randy still thinks, I just spoke to him last week, and he still thinks that there is the difference between scene construction area and theory of mind-like or person-like. That's what we also wrote in 2019, but now I have no idea, and I will be more than happy to hear your opinion about it. Michael, who is now with Russ Epstein in the space community, so he thinks mostly that the main key is the retrospacian complex, which is like a specialized region, and it's everything is space and developed on space. Now trying to convert also Epstein about this. So let's discuss it soon. And this is the DNA DNB by Buckner that you probably know. This is a group average of results, and you see the DNA, which is the TP, the TPJ there here, the more posterior part, and some part of the Precunus and Raspospayan, and the Precunus in the middle is the other network. So this was just a summary about orientation of space-time in person, about gradients and the core system. But this is also, let's move to a newer stuff. Just before going to this, I will share with you that we have a tool that enables to test orientation. The problem to test orientation is that it's highly personalized. You have to know exactly like where the subject lives, what the places around this place, when were the important events in one's life, and who are the people, which is the most bothering procedure. So we designed a chatbot called Clara that first collects automatically all of this information, and then also runs the test. And there is even just a tool that just collects part of the information, and it makes things more convenient, especially if you do things in a large scale. And there is an app that you can download, and it's on the web, and if anybody wants to use it or enjoy it, so just let me know, and I will send you an authorization to be an administrator of your own of your research, and you can use it free of everything. Just use it. It's results come much nicer when you use people's own words and when you use a more generic stimuli. So this was. Is
it fully, just out of curiosity, is it fully anonymized for the users on your part? Coded?
It's the problem if you ask me a question, I have to tell stories, and then we won't have time. And the thing is, but in very short, we have a cybersecurity company that volunteer to make it as safe as everything else. Everything is done by codes. So you receive a code, and then you can decide if the experimenter is anonymous or not. But usually, like we know it ends the subject, nobody else, because you have to have the code, and it's as secure as the use of credit card, which is not very good because the credit card company knows everything about us. But at least here we don't have a credit card company. That's the advantage of being an academy. No money. So no financial interest, so nobody is interested, and everything is supposed to be super secure. And please use it if you like. Okay, so the first question was, do we use the same brain system to represent small and large scale environments? And this is a nice manner that I like to present research questions because there are already several theories. One theory says, yes, it is the same system, and I can check a rat in a cage or check a rat in the field, and it is the same. A second is a dual system. I said, okay, there is the immediate environment, and then there is a far away environment. And the third is multiple. We do remapping if we are in a room, so we have our grid play system for the room, and if we go to another room, it remaps, and then there are several, and there is a system that, so this is one, it's a one system that make itself, that it's remapped again and again, so it's actually an ad hoc system. Or neuroimaging studies, if you look at different scales, so you find different activations, so it's multiple. So what we did, and this was a study that Michal did while in the lab, is to check, to ask people to do the same orientation, similar orientation task, to give us different stimuli of their own world in different scales, like what about their room, about their building, about their neighborhood, and then to be sure about cities in Israel that they know, states and the world that they know, and continents that are not going to them. And the question was like we showed people like one. So here are the stimuli, and we ask people to imagine themselves in a certain building, certain environment, certain city, and we showed them different stimuli, and they had to answer what is closer to themselves. Yeah, what is closer to the mirror, this and this, what is closer. And we can discuss also a very interesting question about egocentric and allocentric. What's the difference if I ask for my distance between these two stimuli, or the distance between one place? I have to imagine myself in one place and show another. Well, I just skip the analysis. It's straightforward. This thing, and then what is not straightforward is the last stage. Then we analyze either the betas or a Gaussian fit of the hemodynamic response. And what we found are nice gradients that go like from the smaller scale to the larger scale in the medial parietal cortex. We found another gradient in the long axis of the hippocampus, and a less nice gradient here in the temporal, almost temporal occipital sulcus. You can see it here by eye, but there are also ways to quantify gradients. This is Noam Saddam-Grossman was in the lab. Now she started a postdoc with Randy Buckner at Harvard, and she developed, was published in PNAS in 2015 in another study, but there was less people didn't adapt the method, though it's an easy method, and also we developed the tool to quantify these things. And this is just to, what the tool does is to identify the centroids on this on each cluster, and then we make different linear fits. We calculate the optimal from all the different linear fits, and then this gives you a number that quantifies the quality of the gradient. So this is just a way to quantify gradients and to get a number, and not just by the eye, that, as we know, can catch everything as long as it's publishable. So, well, we don't have much time, so we skip this. We can quantify the gradients in different places of the brain, and we can also calculate the overlap with the default mode network. And what's nice is to see that the small scales overlap with the visual network, and then the more abstract space, they overlap with the default mode network. So we actually have a support for a multiple scale, because we see integrations multiple scale. We have a support for the dual scale, because we can divide in between the visual and the default mode networks. And we can also speak about a unified network, because it's a one network that goes from smaller scale to larger scale. And we can even quantify the overlap of the region. You see that in the medial parietal gradient. So mostly is the neighborhood, and also in the medial temporal gradient. And then we can speculate about the role of the neighborhood. That the neighborhood is like the parallel scale to the territory of the animal. So this is something evolutionary speaking that may be like the central territory, and the lateral occipital parietal, which is like more visual, so is active most for the room. Yeah, so the interim summary for the first step for this second study that I showed is like there are three posterior anterior gradients for spatial scale that extending anteriorly from the PPI, RSC, and OPA. Posterior parts of the gradient overlap with the visual, and then the anterior with the default mode network. And that there is a difference of the spatial scale sensitivity in between gradients. So questions, Tim here, please.
Yes, I do have one actually. The gradients that you're observing there, are you relating them to some form of perceptual processing or some form of mnesic recollection? I mean, how do you place this representation in the typical perception cognition type of dichotomy?
Well, you have to presume a perception cognition dichotomy, and then to the system. But I just saw the system, and then you brought in the perception cognition dichotomy. For me, is a very I think about it in an evolutionary manner. That there is like first we learned that there is a space, so we started to navigate the space, and to navigate the space, our space, as we became a more and more complicated animal grew again. Then we understood, even as cells, that there are also some other creatures around. Like for example, the study by Didionno in bats, that there are place cells for other species. So we started to create on top of this a social map, and so like this will be like this is basis, and then how you map when you perceive things, you map them on this, but the building blocks are the ecological representations of the different scales, not the perceptions. Like that's the way that I conceptualize it. Let's see also about time and what happens in the grid cell system, and then maybe it will be clearer. Blah. Okay, so now about time. Since the host is Professor Virginie Hasselhoff, so we have to speak about time. And we wanted to make a similar study also with respect to time. The problem was that we started to do the same, like in the building orientation, and nothing came out. So we came with the idea, to make a study or an experiment on events that are encapsulated in space and time. And in Israel, there was there is a habit of people after that they do national service or go to the army to go for a year or half a year. Half a year they work to make some money, and then half a year they go abroad, usually to South America or to Southeastern Asia for a long trip. It's also common in France. Nobody heard about it in the United States, but well. that's what we did, and we asked participants who came, well, now students, and came back from students in the first year, and they just came back from this trip, to think about a specific hour during the trip, a specific day, a specific week, and a specific month. It's not ideal, but it's encapsulated. You can imagine yourself, and if you did such a long, even memorable time, so you can think about it. And then we did a similar design. We asked them to think about one event and then compare to two other events. And then you see the events are also related to space because of the study design. And here we found, again, the scale sensitivity clusters. The gradient were not that nice. Here you can see some kind of a gradient, here not at all. But what we found is that the smaller, that there are brain regions, again, sensitive for the smaller scales, and then in other brain regions that are more sensitive to the larger scale. Here you can see this is a medial parietal, usually or more sensitive to large scale, and the lateral occipitoparietal, similar to space, is more sensitive to the smaller scale. And we also compare it to the default mode network. I don't have this slide here. So, but the results are very similar to space, and then we can speak about sensory to abstract and the default mode network, which represents the more abstract thinking, and the visual network, which represents the more scene construction or visually imaginable environments, like a specific moment or a specific place. Yeah, we also, I didn't bring the slides here, but you can imagine that we did it also for person, again in the same manner. And person was like in the middle in between space and time. There are gradients, but they are not as nice as in space. But the difference in between very close and very and distant people and the default mode network, A and B actually now here are very prominent. So this is about scales in space, time, and person. And the second question that came to us, and this is we just finished to write the paper. I hope to submit it soon, and I will have to. I'm asking really your opinion about it and what you think. Is what happens in multiple scales, like things that are in multiple scales together. Like for example, a given daytime changes according to age. Yeah, if I have my 5 years old at 8 o'clock in the evening, and I have my parents at 8 o'clock in the evening, they are doing different things. So we cannot think just about age or just about or just about the day, the scale of our day schedule. You have to think about them in a conjunctive manner. Or if the same will be not the daytime but the age. So of course, if somebody like each of us in the same age, we do different things in the morning and different things in the evenings, unless we are crazy scientists who are doing the same thing 24 hours a day. But we're not. So we should think about these two together. And the usual suspect was the grid system, because the grid system, and according to our hypothesis, or what Virginie, what you asked, that a spatially dedicated system is modified by time, represent time. So it should be the grid cell, and you all know this timeline of the grid cell, starting with O'Keeffe and Dostoevsky, and then O'Keeffe and Meidel, and then the breakthrough papers, finally the Nobel Prize to the Professor John O'Keeffe and Edward David Moser, and then the advance that was made by Tiff Behren. Well, here in 2010, we had a study in Nature by Christian Doller and our genius friend Niall Burgess that you all know, that modified the grid code into an fMRI paradigm. Tim Burns in 2016 tried to imply it also in more abstract spaces, and this is my brilliant student Greg Peters Feinstein, who applied it to time. Yeah, and now the places, the grid cells. And just to remind you that there are three interesting qualities of grid. One is the grid phase. Another is the grid can go in different phases. Now there's a grid orientation and the grid scale. So all of this can be played out. And what Red did is to have two different movies. One movie is a person going in one direction and becoming older and older. So this will be the day life or the age axis. And this is the daytime axis, also going from morning to evening. And these are symbols. Unlike if people know the studies by Bern, so Bern just did he puts a Christmas symbol. We put here ecologically symbols, like this is a toddler going to sleep, and this is a PhD student going to parties, and this is an older person going to theater. People are doing different things in their evening, and people in the same age doing different things around the day. And we trained people for 4 days to make trajectories around this space, and actually people become very, very good in this after this very short of 30 minutes 4 times of making trajectories. And the trajectory is to go into one symbol, like we see, for example, this person, like when she's like 20 years old, and it will be noon, and they will go there, and they will go very good to this direction. They can and they can even go there, even just by imagining the images, they can go and make the trajectories very well. I will show you a movie. So that this is a movie that they watch, and they see in what direction. And you see that the aging and the day changes in different velocities. And nevertheless, they can really imagine it. And then, for example, in the fMRI, they have to indicate what symbol is closer to the trajectory, where the double temporal space goes. I will show you again. So it looks arbitrary, but no, it's not, and people can do it very, very well, finally. Yeah. Now, Virginie, this is for you. So we also checked the possibility to go backward in time. And if there are differences between movements that are congruent with the error of time and not congruent. And they had different tasks. While participants familiarize themselves with manipulating the age of the person, and when we reinforce them to simulate the change by themselves, or to then to attach it to the symbols, and then finally to test just the symbols. So these were like the 4 different levels of the task. Now, let's see what we found. First of all, our measurement was the number of frames, because like each movie has like different pictures, like different shots that are attached as a movie. So we can measure the number of frames, and you see that people are improving during the training set. Well, this is the fMRI movie paradigm. They had passive condition when they just saw things, the active condition they had to decide, and then the testing condition when they had to indicate where to go. So let's see what we found. Okay, this is a little bit complicated, so I will ask you to concentrate. You see that there is a specific angle in which the trajectory goes in each movie, yeah? And then we say that there are like the different stages. First, the morphing stage, when they saw the movie, then the imagination stage, when they had to ask to imagine where the arrow continues, and then finally the feedback stage, when they had to give the symbol that is in the trajectory. So this gives you, for each trial, it gives you a trajectory, and the trajectories are organized on a space like this. And then we can organize all the trajectories on one scale, and we can see if it obeys a 60-degree hexagonal representation or not. As you can see, even by eye here, you see that there are much more trajectories in the hexagonal than in the non-hexagonal organizations. You can test it in a more in a more organized way if you just calculate a 5-fold organization, a 6-fold organization, or a 7-fold, and you see that this is the right entorhinal cortex, this is the left entorhinal cortex, and you see that the 6-fold is the winner here. So it gives you already the impression or the idea that this time space, so it obeys a 6-fold grid cell-like representation. But for me, but this and this is already a question, because people can say, well, like if our mentor Harold Eichenbaum would be like, maybe you would say, okay, we see that time is the next stage of space, and you see here what happens with the grid on space may also happen also on time, and things change. But nowadays, people may say, okay, Tim Burns already showed us that conceptual levels are represented by grid. So this is one more abstract conceptual study. But this also can be discussed, since first of all, when Tim Burns did his bird space, the science paper 2016 by Alessandro Poglianenzo. So it was actually a space of birds' beak and legs, but a space. And the other studies were about like Dmitry Aronov on the auditory level, olfactory level, but they were not. There was one study also by Tim Burns and Mona Grover about organization of objects, but not a real. So you can say that time is a subset of an abstract thing, but you can say that no, time is actually the next stage following space, and I will be very happy to hear your opinion about it. So this is my question to the audience, and I will, before that I ask you to do that, I will just show you one more result that for me is more interesting, and it's dedicated to Professor Van Wassenhoff, since it shows the congruency of time. Because you can compare trials that were with the time arrow, like from from toddler to older person, and from daytime to evenings. And first here you just see the behavior. You see that the success rate is much higher from congruent trajectories and non-congruent, and the response time are smaller for or lower for congruent trajectories or trials. So this already shows that although the task was very difficult and very technical task, nevertheless, people are faster and more accurate for ecological time movements than for non-ecological. I will also love to hear your opinion about this. And this is also shown in the neural level. The analysis here was to identify the entorhinal cortex and make a mask of the entorhinal cortex, and then to compare the fMRI activity in an MPPA to the entorhinal cortex. And you see that trials that were included in the MPPA and overlapped with the entorhinal cortex, so you see a higher magnitude of the grid cell-like representation. It's a GLM. So you see that in both the left entorhinal cortex and the right entorhinal cortex, and here it's even more prominent, but it's significant in both. So the combination of voxels in the entorhinal cortex that also came out in the MPPA are more significant, or are significant with respect to voxels that were not included in one of these two. So we also see this ecological mental time travel within the era of time and not the other way around on this crazy time space or age day space, and also in the neural level. Yeah, so this is analysis that we don't have time yet, but you can also see it. Yeah. Look. Yeah. So we see that the entorhinal grid system is recruited also for a 2D multiple time associated scales, and this is true by projecting in time according to the error of time more or than in the other way around, or not in the other way around. And then the questions that I would like to pose to you are these properties specific for time, and what will happen in more than a 2D dimension, and do you think that also that it can be also applied in multiple domains, or it's specific for time? And what do you think about the mental time travel, its congruency with the mental time travel? Yeah, so if somebody has some ideas regarding these questions, so please share it with me.